if you have the same camera flown 3 times closer to the ground, you will get 9 times more pixels. So because you can see more details, you can recognize everything much better. The same about the telecommunication. The problem why Starlinks today require these huge antennas to mount outside of the building is because the signal from the phone is not strong enough to reach the satellite, so you have to amplify it. But if you are 3 times closer, your signal becomes about 9 times better, which allows use cases in direct-to-device connectivity, basically internet, satellite internet to any phone, anywhere.
Thank you for listening to Sprint, the podcast of the Federal Agency for Breakthrough Innovation of Germany. I am Thomas Ramge, and I'm very much looking forward to our guest today, Anatolii Papulov. He's a co-founder of New Orbit, a space startup based in the UK that aims to place satellites much closer to Earth than it is usually done, much closer than Starlink and the rest of it does it. Very low Earth orbit, VLEO, is the search word here. Hence, VLEO is both a very promising and a very tricky space for a space startup. Anatolii, welcome to the Sprint Show.
Yeah, thank you. It's very exciting. Thank you very much for inviting me, Thomas.
Sure. So, first principle first. How low is very low Earth orbit?
It's about 200 to 300 kilometer altitude. So it's basically, if you look at what you can see in the sky today is the planes at 10 kilometers and then usually satellites at 500 to 600 kilometers. So we at New Orbit aim to fly at about 200 kilometer altitude.
And why is this tricky? There must be a reason why Elon puts his satellites 300 kilometers higher than you intend to.
Yeah, it's an interesting question. So the simplest way to explain that, if you're on top of Everest, it's very hard to breathe because the atmosphere is very rarefied. But once you start to go down, your atmosphere becomes denser and denser and denser, which becomes a big problem for satellites. If you go from 500 to 600 kilometer altitude down to 200, your atmospheric density starts to increase, and your lifetime before you re-enter the atmosphere and disintegrate is not 20 years, it's a couple of weeks. And you have to, if you want to make use of that satellite that costs millions of dollars, you need to make sure that it flies for close to 5 years. And this is exactly the problem that we've solved inside New Orbit.
But, why'd you go there at the first place? If it's much easier to put them higher, cameras seem to be very good today. So why you want to go low?
But it can become much better. If you have the same camera flown 3 times closer to the ground, you will get 9 times more pixels. So let's say if you can see, let's say, buildings from conventional LEO, you would be able to see maybe cars from flying at VLEO. So because you can see more details, you can recognize everything much better. And the information is everything. The same about the telecommunication. The problem why Starlinks today require these huge antennas to mount outside of the building is because the signal from the phone is not strong enough to reach the satellite, so you have to amplify it. But if you are 3 times closer, your signal becomes about 9 times better, which allows you to unlock entirely new use cases in direct-to-device connectivity, basically internet, satellite internet to any phone, anywhere, which is a dream, and many other things. So the thing is that what satellites do is that they just take the data which come from Earth, and the closer you are to this data, the better data you can get. This is why these altitudes are exceptionally useful for many different applications.
Makes total sense. So why is it so exceptionally challenging to put them there?
Yeah, so the atmosphere becomes a big pain and a big problem that you have to solve for. It's not only about a single subsystem like for example, a propulsion system that we develop in house at New Orbit, but also about your materials, about your attitude control, about your payload structure. What we found is that you basically have to design a new vehicle to operate at these altitudes. The major three problems is the aerodynamic drag. You have basically very short lifetime, that you need to use very specific propulsion systems. You cannot use chemical engines because the amount of fuel and oxidizer that you need to bring is going to be way too large to fit within the spacecraft. You need to use electric propulsion systems. Then you also need to have a very specific attitude control software, because the atmosphere starts to impact your satellite and it starts to behave in a completely different way. Also materials. It just atomic oxygen is, I think, the second most reactive substance in the universe, which was discovered, and it binds with everything. So you have to protect all of the parts of the satellite, including payload.
So let's go to the solutions. That sounds challenging. What do you come up with? Because, obviously you've not been the first one thinking about it, putting it there. The advantages are obvious. How did you came to the idea that, we're going to solve these technical challenges?
So I was looking at this idea for some time within my master's studies. And I have background in physics, and I didn't find any subsystem that, breaks the laws of physics or doesn't allow you to operate at these orbits. Furthermore, there were two satellites that actually flown below 300 kilometers. There is one very famous Gotcha from European Space Agency that flown more than 4 years, close to 5 years, at this altitudes to 40 to 60 kilometers, which is also very exciting. And there is Tsubame from JAXA. And so it's been already done before, but not on the commercial scale. And you need to develop very specific technologies to make sure that it works on a commercial scale. So, and for example, one of the biggest advantages that we have is our propulsion system. So we are using a very specific ion propulsion system that allows you to have a very high propellant utilization efficiency. So what I mean by that is that, let's say if you use chemical propulsion, you will run out of fuel very, very fast within basically months of operating at these orbits. You need to have a very propellant efficient system that allows you to extend lifetime at these orbits. And we developed gridded RF ion thruster that basically has about 4 to 5 times higher propellant utilization efficiency than any other engines that you can find on the market for, small sat factor right now. That allows us to basically reach 5 years operation, even more, on relatively small tank of propellant. I think this was one of the biggest innovations that we did. There is also, we have different solutions for drag reduction, how to make sure that we can fly longer, compensate for less drag, reach lower altitudes and all of that. So there are a lot of exciting challenges there.
What kind of fuel do you use?
So it's xenon. So we actually have two systems within the orbit. There is a breathing system that allows us to scoop the particles right from the atmosphere and use that as a propellant. But also we are using xenon that you basically, it's the best propellant that you can find for existing electric propulsion systems.
Okay. How did you change the design of the satellite?
So it becomes more aerodynamic, which means that it becomes very easy to spin out of control and focus on a specific area if you want to make imagery. So there is a different form factor, how you need to fly. It's a different way how you mount the payloads. Your software is very different. For example, for existing satellites, if onboard computer goes offline for a week or two, it's fine. In our case, if if it goes off for a week or two, we might already be on our way to deorbit and re-enter the atmosphere. So basically every architectural decision we had to rethink to make this happen.
What's the status of the startup? I've seen you've done a nice round. Get some prominent investors. Almost 20 million euros, I think.
Yeah. So we plan our first launch in 2028. So our subsystems, including propulsion system, is very mature. Like some of that already passed the vibration test, some of the parts of the propulsion. We did fully integrated tests with propellant management system that supplies, for example, xenon into our thruster. We have also all of the power, electronics control, and everything already here in the lab. We already next year are moving into much larger facilities with all of the clean rooms where we'll start to assemble our spacecraft already, and after that integrate it into a launch vehicle, and after that go to this very low Earth orbits.
Who's going to launch it?
So it's SpaceX.
Who else? What a surprise. Well, hopefully there'll be competition soon, maybe out of Munich. But
ISTAR is a very interesting option.
Yeah, that would be good. How comes that you're based in the UK?
Yeah, I would say that UK has a great unutilized talent in engineering. Also, very good access to capital, very easy for anyone to move. There are a lot of great things about our location, even specifically Reading. We have, hubs in Oxford, then also in Harwell, in Surrey, and in London, and everyone can come here and work very easily. Yeah, and also we are looking we currently working on our expansion to Germany as well, which is also very exciting to tap into your great engineers. And yeah.
No, interesting. We'll talk about this a little bit later, what you do with Sprint right now. But tell us a little bit about your journey as a founder. How did you come up with the idea? When did you decide, okay, I will not, I think you dropped out of a PhD program. So when did you decide, I'm not going to become a full-time scientist, but I'll be a founder in science?
Yeah. I think my background is in physics. So I got my bachelor degree in physics. I love physics, especially general theory of relativity of Einstein. I was working on very complex phenomena of thermodynamics. But at some point I realized that and I went into physics because I really wanted to find and discover something new. And I found that unless you go into quantum or kind of into space, search for dark matter, it's very difficult to find something, that can really change our understanding about how our world works. And then I went to do my master specifically in aerospace engineering to go to space and actually discover new things. And one of the first things that I found, which was interesting, that there is this very strange kind of tendency that satellites don't fly below 500 kilometers. And I started to ask myself why, and why this is going in the way that it's going. I didn't find any technical reasons why it couldn't be done. Because for me as a physicist, if you can get 3 times closer to the ground, you can see things better, you can communicate better, your, weather sensing becomes better. It's just, if you are just closer to the ground, you can get much better data. And I started to look into this, but at some point, I realized that if you really want to make this happen, it cannot go through the university. Creating a company is really the only way of how you can make that work. So yeah, and basically since then, I think one of the biggest use cases that really inspired me to make New Orbit is that when there is this very big satellite called Worldview 3, It's weighs close to 1 ton, $500 million, takes a decade to build, but it makes the most precise imagery in the world. And once it made an image of 3 ships in the sea, and the resolution was so good that they could recognize illegal activities there, send Coast Guard there, and they found 2,000 enslaved people on board of that ships, and they rescued all of them. And for me, this was a very interesting, I think, analogy that one satellite image could lead to the rescue of like 2,000 people. If you are flying lower, you can make the satellite for not $500 million, but only a few $1,000,000. The impact on economy, the impact on society and the whole humanity is going to be significant. And what I also found that nobody was working on this back then. This was a very challenging problem. And for me, it was just an idea why, it was a very important technology for everyone to work on and to see, to make it happen. This is basically, I understood that this is bigger than anything I would do in my life, bigger than myself, so I have to make this work. And after that, I found my co-founder, Ruslan, who is very good on the technical side, especially on propulsion, and we started New Orbit.
What's the size of a team right now? Who was part of it?
About 30 people. We have really great people. We have people coming from NASA JPL, from SpaceX, from Tesla, from Rocket Lab, all over the world. Everyone comes to Reading because it's funny enough that, for example, Glenn, our technical lead, came from Los Angeles to Reading to work for New Orbit, which is very, very rare to see.
Where's Reading?
So Reading is, it's very close to London.
To London, so north of London, right?
Yeah, it's about 1 hour, door to door if you want to get to central London. But it's very good infrastructure in terms of you can get from London to London. It's not as expensive as London. But it's a great place.
Who'll be your potential customers? Who are going to pay for it?
I would say anyone who is looking for better imagery for their payloads, for their missions. They would look at flying on our satellites. Also, somebody who is looking to build direct-to-device connectivity, which is a very big topic right now. Weather, also science is a big thing. Because when you are flying at this altitude, nobody really flown there. There were 2 satellites, but there are a lot of questions that you also can answer on the scientific basis. I think that there are plenty of applications which are very important at these altitudes.
Spy agencies?
Yeah.
They might be very interested. Aren't they? Did they already contact you, military?
Not yet.
We'll see. Okay. So what are the upcoming milestones? What's the plan within the next 2 or 3 years?
So it's mainly getting satellite up in orbit and also making sure that we have the capacity to also build all of the following satellites. So this is what is exciting about NEO production complex that we are building. We are already building the bigger facilities. Right now we are in the relatively small ones. So next year is going to be about 2,000 square meter facilities with clean rooms that can accommodate initially a few satellites a year, but we would be able to scale it to very easily to 10 satellites, then a couple of satellites a week over time. Then basically next year, end of this year already, we will start receiving some of the subsystems for the spacecraft. We'll start working on them and do a lot of testing. Next year, we'll start to do the assembly of the spacecraft, make sure that this is ready for the launch in 2028.
And how about the business plan? When do you intend to sort of sell the first high-resolution picture to a commercial customer, and how much money will you still need until getting there?
So our main business model is not to generate imagery by New Orbit. It's mainly to provide a satellite platform that would allow our customers to generate this imagery. So what we focus on is basically selling satellite buses that allow you to basically go to these orbits. Because right now, the challenge that we see in the entire industry is that there is still, while there is about 50 entities that can build LEO satellites for you, there is zero that have a ready-to-fly system that will deliver you to this very low Earth orbits. This is what we aim to bridge as a business model. We want to have, affordable and frequent launches to this very low Earth orbits that allow you to test your payloads, to fly these altitudes, to also get the benefits, much higher resolution, better communication, and all of the other exciting applications.
I see. If I understand it right, I mean, obviously that is a very empty space, and that is basically the business case of you, occupying an empty space. Are there any other startups you know of that work on that approach? I mean, it sounds quite obvious. The VLEO was an interesting space for everybody knew about it for 60 years, and everybody said, okay, we're going to avoid this space because it's just too expensive, too complicated to find solutions. So and as technology evolves, obviously, people like you come up with the idea. Maybe we get the trick. We find solutions. Are you the only ones? Are the other ones?
No. There are some other companies looking at these altitudes. There are, even startups or big primes from US to Europe and India. So there are a lot of people who are looking into this. But I would say it's still a question whether anyone can build the satellite reliable and affordable enough to fly at these altitudes. Plus, what really differentiates us from everyone else is our propulsion system. That allows you to fly lower than anyone. That gives you much better performance, as well as longer than anyone, because we have such a high propellant utilization efficiency of our propulsion system.
Okay, and now, first, who are your investors? Quite prominent names among them, I've seen.
Yeah, so this round was led by Voyager Ventures. Then we also have continued support from Atlantic Labs, who actually wrote the first check for New Orbit. We also have Lifeline Ventures in Finland, who also invested in ICEYE or Aura Ring. Then we also have different very exciting angels, like, for example, David Kirk, who was Chief Science Officer at NVIDIA, Lawrence from Tier Mobility, one of the European unicorns. We also have other, very interesting family offices and angels as well.
And now you're doing what we call at Sprint a validation contract. What exactly do you do with Sprint?
So we are looking right now at the fundamentals and architectural solutions required for our satellites. So we right now are going and building the systems that allow us to basically go deeper into the different topics. So with Sprint specifically, it is communication, how communication is done at these altitudes, what are the challenges, because you are flying a bit faster, your angular velocity would be faster compared to conventional LEO satellites, image stability, as well as the materials which are required for these altitudes for specific subsystems, which is very exciting. It was one of the kind of fastest contracts that we ever got. And right now we also have the plans to expand to Germany as well.
What are you going to do in Germany?
I think what Germany is really exciting is that it's a very growing market with a lot of very smart and passionate engineers who want to build incredible things. We want to tap into this, and over time we want to make Germany our gateway to this very low Earth orbits on the industrial base. So one of our manufacturing facilities are going to be in Germany to supply all of the satellites to the entire European continent.
So when will this gonna start, if anything goes according to plan? So when you get into
We already started to put the process in place. We planned for about 28, 29, where we will open our facilities in Germany.
Do you consider New Orbit to be a European project? And if so, why do you do it here and not in the US, where possibly many circumstances might be more favorable to space startups?
It's definitely a European one. And I think it is a big achievement for entire Europe, what we do at New Orbit. There is a lot of, for example, right now, race for sovereign launchers and many other things. But VLEO capability, it's something that doesn't exist in the entire world. And the fact that we're opening this from Europe is really exciting. I think Europe is really good in talent. When I was at MIT in US, when you ask everyone, where do you want to work? Like you ask aerospace engineers, everyone wants to work at SpaceX. But there is no such company here in Europe, in a way that there is such large pool of talent, which just doesn't know what to do with their engineering degree, who really want to build amazing stuff, but they don't have the companies to actually go and build something. This is why we see that there is a very big gap, first of all, in the talent, as well as right now there is a very big sovereign market. We see that the European space ecosystem will grow very, very rapidly over the next 5 to 10 years. This is a chance for us to build one of the biggest companies in space by unlocking these orbits. Yeah, so I think there are a lot of great benefits of doing this from Europe rather than US.
Did you ever want to work for SpaceX?
Yeah, I think at some point. I mean, this is a very exciting company. Yeah, for sure.
Of course. Well, we're glad that you chose another path to very low orbit. The last question I ask to all my guests is always the same. What kind of radical innovation you wish for? What kind of innovation leap you wish for the year 2050, which has nothing to do what you're doing?
I would say fusion would be great.
Yeah, you're still a physicist, right?
yeah. I think it's been a topic for quite some time. But abundant energy can really solve so many things for us, and even right now with even data centers going into space, because it seems that power is becoming cheaper if you use Starship and launch it into space. But the thing, abundant energy would be great, and this would be a really next step for this civilization.
It would also be good to have more rocket fuel, right?
Yeah, so definitely. If you look into space, I think going beyond Earth is really exciting. Also, harnessing power of the sun is very exciting. There are many areas that I would love to see in 20 years. It's still very, 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 very short.
Yeah. It sounds 2050 sounds like distant future, but obviously it's not. Do you believe in these data centers in space? Do you think it's feasible? Is it viable?
Yes. I think it all, of course, relies on Starship, but the thing is that why it becomes very important now is because if you want to order a gas turbine to generate power, you only will have this delivered in 5 years, 6 years. It's very hard to find power right now on the ground, and even Eric Schmidt bought relativity because he was saying that 99% of all power is going to be data centers and connected to AI. When you're going into space, your power goes from, let's say, 60, 80 watts per square meter to 1,300 per square meter. It's a 20x difference. And if you can find out the way of how you can deploy this infrastructure in a very cheap way, you can make sense of it. So because what is so great about Starship is that it's basically a fully reusable vehicle, and it's basically only operational costs and the cost of fuel. But I know they're using fuel which is even cheaper than the fuel that commercial airlines are using. So if it's just about the operational costs and also the cost of fuel, it will make sense to put power into space.
And even if you have fusion, because that was your wish, you want to have fusion. If you have fusion, do we need still space centers in space, data centers in space, or can we just run them here next to the fusion reactor?
Yeah. I think fusion can solve this. Yeah, for sure. It's just fusion have been in minds for quite some time.
Yeah, I thought with fusion you get cheap hydrogen. I don't know, so I can bring a lot of stuff up in space. Anyways, Anatolii, thank you so much for the conversation. We wish you all the luck for aiming low would not be the right claim for you, though. You are aiming for the orbit, right? But you aim high, it's still high enough. We wish you all the luck with it. And thank you for partnering with Sprint.
Yeah, thank you very much, Thomas. It's a big pleasure to partner with Sprint. It's one of the best experiences that we ever had. And looking forward to what comes next as well.
Thank you.
Thank you for inviting me.
And thank you to you, dear listeners. If you like our podcast, we would appreciate if you could leave us a rating or a review. This podcast episode has been produced, as all the other ones, by Max Zöllner. Thank you, Max, as always. In 2 weeks from now, we're going to be out with the next episode. Until then, as always, stay curious.